In this video, we're going to be doing some polynomial division. Let's start with a definition. A polynomial is a finite expression with positive whole number indices. So finite, meaning it has a countable number of terms. It doesn't stretch into infinity. And positive whole number indices or exponents, meaning we cannot have fractions as powers here. So these are all examples of polynomials. X plus 3, x squared plus 3x plus 10, 5xy plus 3y take 9, 10 or 2x squared. They are all polynomials. Things that are not polynomials are things like the square root of x. If you write that as a power, that would be x to the power of a half. So the power would be a fraction and not a positive whole number, index number. 15x to the power of negative 2 is not a polynomial, and 6 on x is not a polynomial. Another way to write this is 6x to the power of negative 1. That is not a positive whole number, index number, so we do not call this a polynomial. Some other useful words are these over here. The first one is monomial. This is a polynomial with one term, for example 10 or 2x squared. You can refer to as monomials. A binomial is a polynomial with two terms. That's things like x plus 3, x plus 1, x plus 4, or it could be x cubed plus x or something. As long as it has two terms, you can call it a binomial, and a trinomial has three terms, things like x squared plus 3x plus 10, or 5xy plus 3y take 9. All right, let's jump into some examples then. And I'm going to do the first one here using long division. So the question is, divide x cubed plus 6x squared plus 8x plus 3 by x plus 1. And for this first example, I'm just going to show you the method. I'm not going to explain how any of it works. In the second example, I'll explain why we're doing what we're doing. Okay, so for this first one, we are going to use long division. This is very similar to long division with numbers. But now we are using polynomials. So set up your division, write your dividend like so underneath that sort of division looking thing, and then write your divisor out the front. And what you begin with here is dividing the first term in the dividend, x cubed, by the first term in your divisor. So x in this case. So x cubed divided by x is going to be x squared. And also what you want to do here is, just like when you are multiplying or dividing with numbers, you keep things in their place value. We're going to do the same thing here. So x cubed divided by x is x squared. So we're going to put that in the x squared column, so above the 6x squared. The next step is to multiply this quotient that we have, x squared by x plus 1. So x squared times x is x cubed. X squared times plus 1 is plus x squared. Then subtract this product here that you just got from the first two terms in the dividend. X cubed take x is going to be 0, so we don't have to write anything here. Let's focus on the 6x squared take x squared. That's going to be 5x squared. And then carry the next term in the dividend down. Write that next to the 5x squared. Then divide the 5x squared by x, the first term in the divisor. 5x squared divided by x is plus 5x. Again, keep things in their correct place value. Then do this multiplication again. So multiply the next term in the quotient by x plus 1, our divisor. So 5x times x plus 1. And this is going to go underneath the product we just got before. So 5x times x plus 1 is 5x squared plus 5x. Subtract these. 5x squared take 5x is 0, so we don't have to write anything again there. 8x take 5x is 3x, and then carry the next term in the dividend down, plus 3. Then divide the 3x by x. 3x divided by x is plus 3. Then multiply 3 by our divisor, x plus 1. 3 times x plus 1 is 3x plus 3. Subtract these. 3x take 3x is 0, and 3 take 3 is 0. And now that we've ended up with 0 in the constants column, the last column of that polynomial, that means we are finished. And we have no remainders. So therefore, to finish this off, we can say that the divisor multiplied by the quotient, that's the answer we just got from our division, is going to equal this cubic. So usually we can finish these problems off by writing it like this. We can say x plus 1 multiplied by x squared plus 5x plus 3 from up here is equal to x cubed plus 6x squared plus 8x plus 3. So if you expand out those brackets, you will get this cubic. So you can see that polynomial division is a way of factorizing polynomials that you can't really see the factors of straight away. It's not like a quadratic. You probably have a bit of practice at factorizing quadratics, whereas when you get to cubics or quartics or even higher degree polynomials with higher powers, it's harder to see those factors. So you might want to use polynomial division in order to factorize those. All right, so we looked at those steps, and I'm going to do some more examples so you can really get the hang of this. But why does this work? Why am I following these steps? Well, let's look at another example. I'm going to use a different method. I'm going to use the grid method because this illustrates why we are taking the steps we're taking, I think, more clearly than this method does anyway. So to use the grid method, firstly, we're going to set up our grid. Now we've got a cubic divided by a binomial. So what we're going to get as an answer is a quadratic. So the grid we're going to have is going to be 2 rows on the side and 3 columns because there's 2 rows on the side for the binomial and 3 columns for our quadratic as our quotient. All right. So, okay, I'm just going to set it up like that. Write your binomial on the side. I usually include the sign with the second term. And what you start off with here is writing the first term of our dividend. So the first term of this cubic is 6x cubed. That goes in the first box. And the first question you ask yourself is, what is this divided by x? So 6x cubed divided by x is 6x squared. And then multiply this term by plus 4. So 6x squared times plus 4 is plus 24x squared. And now it's sort of illustrating what we're doing. We're reversing multiplication, right? That's all the division is, but we're doing it in sort of a clever way. And we're actually taking the exact same steps as we did here. It's just, set out differently. Okay, the next step is to say, well, I've got this 24x squared and 27x squared in our dividend. What do I need to add to 24 to get 27x squared? That's going to be 3x squared. Then divide that by x. 3x squared divided by x is plus 3x. Multiply 3x by 4. That's plus 12x. What do I need to add to 12x to get 14x? That's plus 2x. Divide 2x by x. That's plus 2. And then multiply plus 2 by plus 4 is plus 8. And then what do I need to add to 8 to get plus 8? That's 0. And now I have a 0 at the very end. That means I'm done and I have no remainders. So this binomial divides this cubic evenly, and we can finish up by saying that x plus 4 multiplied by 6x squared plus 3x plus 2 equals this cubic, 6x cubed plus 27x squared plus 14x plus 8. And I'd like you just to look at the final result of this grid here. This could be a division, it could also be a multiplication. I might have multiplied this quadratic by this binomial, and this is what I'd get. And remember, when you do a polynomial multiplication in this way, you need to add the like terms. So we'd do all our multiplication, we'd add these x squareds and these x's, and we'd end up with this cubic. And all we do to reverse that division is reverse that process. So we start with the cube term, divide it, get our first term in the quotient, multiply, figure out what the next term is, divide, multiply, and so on. So I hope that sort of illustrates why we're taking these steps. As I said, they're the exact same steps as we're doing in the long division, it's just set out differently. Okay, so I'm going to actually continue using the long division method because I think it's easier to use when you get harder problems. The grid method sort of gets a bit more complicated the more difficult the problems get, whereas the long division method stays exactly the same. So I'm going to continue using that for the next few questions. This question says divide 3x to the power 4 plus 8x cubed minus 11x squared plus 2x plus 8 by 3x plus 2. So this is a quartic divided by a binomial. And again, we're going to use the long division method. So set that up, write your dividend and your divisor. First step is divide the first term in the dividend by the first term in the divisor. So 3x to the power 4 divided by 3x. That's going to be x cubed. Remember, keep things in their correct place value. Multiply x cubed by 3x plus 2. That's going to be 3x to the power 4 plus 2x cubed. Subtract these. 3x to the power 4 subtract 3x to the power 4 is 0. 8x cubed take 2x cubed is 6x cubed. Carry down the next term in the dividend. Then divide 6x cubed by 3x. That's plus 2x squared. Then multiply that term by the divisor. So 2x squared times 3x plus 2 is 6x cubed plus 4x squared. Subtract these, that's 0. And then negative 11x squared take 4x squared is negative 15x squared. Carry down the plus 2. X. Negative 15x squared divided by 3x is negative 5x. Multiply that term by the divisor, negative 15x squared, and then take 10x. Subtract these. Now, when you have lots of negatives, I would generally suggest putting brackets around that just so you don't get too confused. That's negative 15x squared plus 15x squared is 0, and then plus 2x take negative 10x is 2x plus 10x is 12x. Carry down the plus 8. Then 12x divided by 3x is plus 4. Plus 4 times 3x plus 2 is 12x plus 8. Subtract these. We have a 0 in our constants column, and that means we're done. So again, to finish off, write your divisor multiplied by the quotient, which is x cubed plus 2x squared, take 5x plus 4, and this is equal to our quartic. All right, hopefully that's all good. Now, in the three examples I've done so far, notice with this cubic here, we had a cube term, then an x squared term, then an x, then a constant. In this cubic, we had the same thing, x cubed, and then an x squared, an x, and a constant. You can think of these sort of as like place values. So if you had like a number in the thousands, like, I don't know, 2172 or something, this is the thousands, this is the hundreds, tens, and ones. You can sort of think of these terms as having sort of place values. Same with this quartic, we had an x to the power 4, x cubed, x squared, x, and a constant on the end. Sometimes you don't have such neat polynomials, right? You might have some of these terms missing. So in the next example, we're going to look at how to deal with that. So this problem says divide 2x cubed, subtract 7x plus 3 by x plus 3. You notice we don't have an x squared term here. And in order to use polynomial long division, we actually need to sort of fill in that place value with a placeholder. So whenever you have missing terms like this, you need to set up your division like so. So when you're writing your dividend, 2x cubed, then you get to the x squared term, fill that in with a 0x squared. And then we have negative 17x plus 3, and this is divided by x plus 3. So just to make a bit of sense about this, if I were to ask you to divide 105 by 3, for example, you wouldn't then go ahead and do 15 divided by 3, right? You need that 0, you need that placeholder to tell you that this is the 100s column. So we actually have 105, not just 15. The same principle sort of applies here. When we're dividing by this binomial, if we don't have that placeholder, this algorithm sort of thinks that there should be an x squared term, and it doesn't work quite so smoothly. So it makes it much simpler if you just add that 0x squared in, and then you can follow just the same process as we've been doing. Okay, so let's have a look at what that looks like. So the first step. Can you tell me what the first step is here in this long division process? That's right, it's 2x cubed divided by x. That's 2x squared. So there's another reason to add this sort of placeholder of 0x squared so that the terms in the quotient have a place to go, right? Where would I write this 2x squared if I didn't have this 0x squared in the dividend? The next step, multiply 2x squared by our divisor, x plus 3. That's 2x cubed plus 6x squared. Subtract these. That's 0, and then 0x squared take 6x squared is negative 6x squared. Carry down the next term in the dividend. Divide negative 6x squared by x. That's negative 6x. Multiply negative 6x times x plus 3 is negative 6x squared. Take 18x. Subtract these. Put brackets around it when you have negatives in there. Negative 6x squared plus 6x squared is 0. Negative 17x plus 18x is x. Carry down the next term in the dividend. X divided by x is plus 1. Multiply those. 1 times x plus 3 is x plus 3. Subtract those, and then we get 0 in the constants column, and we are done. So then we can write that x plus 3 multiplied by 2x squared take 6x plus 1 is equal to our cubic. Alright, so that's how we're dealing with missing terms. Let's look at an example with a power of 5 in it. So here we have 21 x to the power 5 plus 29 x to the power 4 take 10x cubed plus 42x take 12 divided by 7x take 2. The reason I'm showing you this example is because there are just a few little steps in here that are a little bit tricky, and I'll show you how to deal with those. Okay, so write out your dividend, and I've actually forgotten something in my dividend. Can you spot what that is? That's right, I'm missing an x squared term, so I actually need to add that placeholder in. Okay, so 0x squared plus 42x take 12. I'm sure you caught that. Okay, the first step is to divide the first term in the dividend by the first term in the divisor. So 21x to the power 5 divided by 7x is 3x to the power 4. Multiply that term by our divisor. That's 21x to the power 5. Take 6x to the power 4. Subtract these. 21x to the power 5, take 21x to the power 5 is 0. 29x to the power 4 plus 6x to the power 4 is 35x to the power 4. Carry down the negative 10x cubed. Then divide this term, 35x to the power 4, by 7x. That is plus 5x cubed. Multiply that term by our divisor. You always know what this one's going to be. It's always going to be the same because we just divided that number by this first term. So you could technically not write this, but I've found that skipping this step can add some extra confusion. So I generally still write this, even though it feels like you're just repeating yourself over and over, and you know what it's going to be. I still add that step in because otherwise it gets a bit confusing. Okay, 5x cubed multiplied by negative 2 is negative 10x cubed. Subtract these. Then we get negative 10x cubed plus 10x cubed. Oh, what's that? I've got 0x cubed. Does that mean I stop? No, because we need to get to 0 in the final place value column. A 0 anywhere else, you keep going. So what does this look like? Well, 0x cubed divided by 7x, 0 divided by anything is 0. So we just write plus 0x squared. You could write plus 0 if you like. I generally still keep the x squared just so I know sort of what's going on and where that came from. But if you just want to write 0, that's fine as well. Multiply this 0 by this binomial. And I've also forgot to carry down that x squared. Multiply the 0, we're just going to have 0x cubed plus 0x squared. Subtract these, well, that's again going to be 0x squared. Carry down the next term. This feels a bit funny, doesn't it, writing all these zeros? But anyways, let's keep going. 0x squared divided by 7x is again 0. x, and then multiply that. Again, we get the 0x squared plus 0x, subtract these, and now we've got 42x take 0x, that's 42x, and we finally have something other than 0. Carry down the negative 12, divide 42x by 7x, that's plus 6, multiply plus 6 by 7x, take 2, that's 42x take 12, and we end up with 0 in our constants column. Okay, so we had quite a few steps there and lots of zeros in the middle. Just be aware that if you do get 0 in some other place value other than the constants on the end, just keep going. It might feel weird to write all of these zeros out, but eventually you'll get to the right answer. So just to finish this off, and I've run out of room, we could write the answer as 7x take 2 multiplied by 3x to the power 4 plus 5x cubed plus 6. So we don't have an x squared term or an x in our quotient here, and this equals our dividend. So 21x to the power 5 and so on. On to the next one. This is an interesting problem because this is actually an identity that's useful to be familiar with, but we're firstly going to use long division, then I'll show you the identity and the shortcut, if you will. So we have lots of missing terms in this polynomial. We have no x squared terms, so let's write 0x squared, and no x terms, so let's write 0x, and then a negative 1 on the end. Then write your divisor, and actually maybe you'd like to give this one a go yourself. Now that we've gone through a few examples, maybe you are feeling brave enough to have a go all by yourself. Alright, the first step is to divide the first term, x cubed, by x. That's x squared. Multiply by the divisor, x squared times x take 1. It's x cubed take x squared. Subtract the first two terms in the divisor by these terms down here. X cubed take x cubed is 0. 0x squared take negative x squared is plus x squared. Carry the next term down. Divide x squared by x, that's plus x. Multiply that term by x take 1. X squared take x. Subtract these. X squared take x squared is 0. 0x take negative x is plus x. Carry the next term down in the divisor. X divided by x is plus 1. Multiply plus 1 by x take 1. That's x take 1. Subtract these, and we have 0 in our constants column. And we are done. So then we could say that x take 1 multiplied by our quotient, x squared plus x plus 1, is x cubed take 1. Okay, so what is this identity? Well, this is actually something called the difference of two cubes, right? We could write 1 as 1 cube. So this is the difference of two cubes, and this is an expression that has a general solution for its factorization. So we can say that a cubed take b cubed in general, no matter what these terms are, this will always work. This is going to be a take b multiplied by a squared take plus ab plus b cubed. Okay, so that's the identity for the difference of two cubes, which we just did here for x cubed take 1. You can see this is a take b, or x take 1, multiplied by x squared plus 1x, which we just wrote as x, plus 1 squared, which we just wrote as 1. Okay, so there we go. Alright, on to the next one. Now, after all of these examples where the divisor divided the dividend evenly, you might be asking, what if the divisor does not divide that polynomial? What if there is some remainder? Well, let's have a look at an example involving a remainder and see how we deal with that. So firstly, set up your problem as we have been doing and follow all the same steps as we have been doing already. So negative 2x cubed divided by x is negative 2x squared. Multiply that term by the divisor. 3x squared take 8x squared is negative 5x squared. Carry down the next term in the divisor. Negative 5x squared divided by x is negative 5x. Multiply negative 5x by x take 4. This is negative 5x squared plus 20x. Subtract these. Negative 5x squared plus 5x squared is 0. 12x take 20x is negative 8x. Carry down the plus 20. Negative 8x divided by x is negative 8. Multiply negative 8 by x take 4. That's negative 8x plus 32. Subtract these. We get 0x, and then 20 subtract 32 is negative 12. So this is our remainder. And because we cannot divide negative 12 by x, in other words, there's no x term in this remainder, we end there and we just call this the remainder. And the way we can write this is to say that these factors, x minus 4 multiplied by negative 2x squared take 5x take 8, subtract the remainder, will equal our original cubic. So you have that remainder on the end outside of those two factors. And if you expand all that out, you should end up with this cubic here. Okay, so that's how you're dealing with a remainder. You just get down to that final term, and instead of a 0, you'll get some constant there, and you can write it like this. I'm going to do 2 more examples. In this second last problem, I'm actually going to show you a bit of a shortcut. This method is called division by inspection. And it's good if you have, for example, a cubic and a binomial. I would suggest this is a much faster way to perform the factorization than long division. The question says divide 12x cubed plus 5x squared plus 2x take 1 by 4x take 1. It starts off by saying, well, if we did this division, we'd end up with 4x take 1 multiplied by some quadratic equal to this cubic. So start off by writing your problem this way, and then think about what this quadratic might be. Well, we know if we expanded out these brackets, the first terms multiplied need to be 12x cubed. So you can actually figure out what this first term will be just by inspection. This is why this is called inspection, right? What times 4x equals 12x cubed? That's 3x squared. Expand those out, you get 12x cubed. Then the last term you can figure out as well, because we know that this final term in the quadratic multiplied by negative 1 must be negative 1. What multiplied by negative 1 equals negative 1? That must be plus 1. Okay, so we've already figured out 2 terms in our quotient here, 3x squared and plus 1. The only thing we're missing is the middle term. So I'm going to fill that in with a b, because I don't know what it is yet, but I can figure it out. The way we do this is to look at our cubic, and you could either look at the x squared term or the x term. I'm going to look at the x term. This is plus 2x. And how many x terms would I get if I expanded these brackets out? Well, I'd have 4x times plus 1, that's 4x, and negative 1 times bx, that's negative bx. There would be no other x terms when you expand out these brackets, right? 4x times 3x squared is a cube, x cubed. 4x times bx is an x squared. So there's no other x terms other than these two. So these added together need to equal plus 2x. So we can say 4x take bx equals 2x. What does this tell us? Well, looking at the coefficients, we can say that 4 take b equals 2. And then 4 take what equals 2? Well, b must equal 2, right? 4 take 2 is 2. Okay, so then we have our answer, 3x squared plus 2x plus 1. So just to finish off, let's write that out. Okay, so you can see I sort of solved that just by inspection, just by looking at the terms and seeing what they must be. Now let's look at a possible follow-up question you might get when you're doing polynomial division. So this question says, show that 12x cubed plus 5x squared plus 2x take 1 has one real solution. What is this talking about? We need to look at the quotient we just got, the result of this division. So 3x squared plus 2x plus 1. And because this is a factor of this cubic, if this quadratic has real solutions, then this cubic will also have those same real solutions. So let's see if this quadratic has any real solutions. We can do this by looking at the discriminant. Remember the discriminant, so let's write that down. Discriminant is b squared take 4ac. So what would the discriminant be for this quadratic? Well, let's plug in the numbers. So b is 2, so we get 4 take 4 times a is 3, c is plus 1. What would this be? This would be 4 take 12, that's negative 8. That's less than 0, so we can say that b squared take 4ac, the discriminant, is less than 0. Do you remember what that means? That means that that quadratic has no real solutions. Let's write that down then. So 3x squared plus 2x plus 1 has no real solutions. And because that is a factor of this cubic, and the only other factor of this cubic is 4x take 1, that does have one real solution. That means we can say this cubic has one real solution, which is going to be 1 on 4, right? That's the solution of this factor when this equals 0. So just to finish this off, therefore 12x cubed plus 5x squared and so on has one real solution, which is x equal to a quarter. Lastly, I wanted to look at an example where we have a quartic divided by a quadratic, just to show you that it doesn't matter whether you're dividing by a binomial or something else, you can still use long division. So let's set up our division as we have been doing. And this starts off exactly the same way. So x to the power 4 divided by x squared is x squared. Make sure you're keeping the things in their place values. Multiply x squared by x squared plus x plus 1. That's x to the power 4 plus x cubed plus x squared. Then subtract these. X to the power 4 take x to the power 4 is 0. 2x cubed take x cubed is x cubed. Then 3x squared take x squared is plus 2x squared. Carry down the next term in the dividend, as we have been doing before. Then divide this first term by x squared. X cubed divided by x squared is plus x. Multiply plus x by our divisor. This is x cubed plus x squared plus x. Subtract these. This is 0. 2x squared take x squared is x squared. 2x squared take x is plus x. Carry the next term down. Divide the first term, x squared, by x squared, that's plus 1. And then multiply plus 1 by our divisor. This will be x squared plus x plus 1. Then subtract these and we get 0. So then we have our quotient and we can say that x squared plus x plus 1. And actually, you might notice something here. Our quotient is the same as the divisor. So we could actually write x squared plus x plus 1 squared equals our dividend. There we go. Even though I went through a lot of examples in this video where we're dividing by a binomial, you can still divide by, a trinomial or something with higher exponents, and this long division method is still going to work in the same way that we were doing it with binomials. Alrighty, I hope you found that video useful and helpful and all of that. I hope I didn't go through those problems too quickly and you could follow all the steps I was doing. Let me know which method you prefer. Do you prefer polynomial long division? Do you prefer the grid method, or do you prefer solving by inspection? Let me know in the comments. Leave a like if you appreciated this video and subscribe if you want to see more content, and I'll see you in the next one. Bye for now.